Welcome back to lecture 2 of our course. In the previous course lecture, we have talked about how the model of System 1 and System 2 influence our decisions, right? And in this lecture now, we're going to continue on and we're going to talk about some fundamental aspects of behavior economics. Prospect theory is one of the most important pieces of behavior economics, and that's what we're going to talk about in this lecture. So, how this prospect theory came about? There is an ongoing debate between economics and psychology around the question, are humans really rational? If you ask this question next time you'll find yourself at a party with both economists and psychologists, ask this question, then step back and watch the sparks fly. It's not that the economists don't recognize that human mind is not always rational. They do on occasion. However, they believe that this occasional outburst of human irrationality or human irrational behavior they don't matter that much. They're happen every once in a while, and they call them anomalies or paradoxes. And for a long time, these anomalies were pushed aside because they didn't fit the model, the smooth out model of mathematical logic that they implemented. So the economists considered these anomalies as distractions from the main event, which in their mind was developing models and theories that explain economic behavior. And with the advent of computers after World War II and more computational power, this is how things went in the economics for a long time. They were able to just focus on creating models for economic behavior. In the psychology side, these anomalies are treated very differently. They are not seen as irrelevant oddities, but rather regularities. They are evidence of what's really happening beneath the surface as we make decisions. So, if you're interested in the cognitive machinery that manufactures decisions in our minds, then these anomalies are actually gold mines, because they show how people consistently diverge from clean, elegant, rational models, and they are clues of what really goes on inside a person's mind. So, prospect theory comes in and trying to address these anomalies. Okay, prospect theory was developed by the godfathers of behavior economics. You know them by now, Daniel Kahneman and Amos Tversky. And they wanted to convince the economist, not only the psychologist, that there might be something else going on in our minds. Their most influential paper in decision making was published not in a psychology journal, but in the Econometrica, the most influential journal at the time, one of the hardest of the hardcore quantitative economics journal. And Amos Tversky was the scientist that was interested in teaching and showing the economists that there are other things beside their models that should be taken in consideration. The prospect theory was called as such because it evaluates how people make decisions around gambles or prospects. Economists love looking at gambles because they incorporate fundamentally important concepts in decision making, two of them, risk and payoff. And when framed in terms of gambles, these concepts can be easily and precisely manipulated. For this most important paper in decision making, Daniel Kahneman and Amos Tversky were labeled the godfathers of the modern decision science, as I said, and this paper earned Daniel Kahneman a Nobel Prize in 2002. Sadly, Amos Tversky has died earlier in 1996, and he could not share the prize, since the Nobel Prize is not given posthumously. In fact, like I said, Amos Tversky was a driving force behind the theory, and their story is brilliantly described in the Undoing Project by Michael Lewis, which I totally recommend. So let's take a look at this Nobel Prize winning theory. So I'm going to ask you, what would you choose in this gamble that you see? Gamble A, 50% chance to win $1,000 and 50% chance to win zero. Or B, $450 for sure. How would you go to choose about this? Well, the economic theory tells you that you should calculate the probabilities of each gamble and choose accordingly. So in the expected utility theory, the utilities of outcomes are weighted by their probability. So you do something like this: 50% times 1,000 plus 50% times 0 is $500, or in option B, 1 times 450 is 450. So you should choose 500. Is that what you chose? I'm going to wager that you didn't. I'm going to venture and say that you probably chose 450 for sure, a sure gain. Why? Well, we'll see. So in their paper, in the prospect theory, they introduce the certainty effect, which says that humans choose to overweight outcomes that are considered certain relative to outcomes which are merely probable. In other words, you rather go for the gain, the sure gain, rather than taking the gamble. Okay. Let's give another problem here, problem 1 called the Allais Paradox. So let's see, choose between this probability, A, what would you choose? Or B, right? So in choice A, you have to choose between $2,500 with probability of 33% and $2,400 with probability 66%, or option B, choose between 0 with probability 0 or 2,400 with certainty of 100%. Okay, so in this case, 82% chose B, 18% chose A. How about this, right? If you have a choice between 2,500 with probability 33% and 2,400 with certainty 34%, okay, this is the complete problem. 83 people chose C and 17% chose D. So what is going on in this? Why are we not calculating properly based on the expected utility theory? So I'm going to introduce now a graph called the value curve, which was part of the prospect theory. So if you look at this graph now, you will notice that there's few pieces of it, right? This curve is called the value curve, and it takes an objective value on the horizontal axis. So imagine that on the horizontal axis you have an objective value, something concrete, and that's easy to measure, like money or horsepower or megapixel. And it translates it into a subjective value, or simply put value, or how happy it makes us, or how much pleasure we get out of it. Okay, so this curve, the value curve, translates an objective value into a subjective value. So it takes money in our case, and it translates how do we feel about it. Okay, so on this quadrant, you see 4 quadrants, only 2 of them are of importance for us. On the top right quadrant, that's the gain part, and on the bottom left quadrant, it's the losses part. Okay, the losses quadrant. So let's see, what do we notice when we look at this curve just by looking at it? It's very simple. I kept it simple with the purpose for us to look and discuss it. So there are 3 things that we notice here. First of all, 1, the curve has a reference point at the origin, the 0 point of the curve. You see it in the middle where everything intersects. The second property of this curve is that as we move away from the origin, from the 0 point, the curve is characterized by diminishing sensitivity. That is, the curve flattens out bending towards the horizontal axis as it gets further from the reference point. You see that on both gains and losses quadrant. And the third characteristic, the third property of this curve, is that it's kinked at the 0 point. That is steeper in the domain of losses, it falls quicker in the domain of losses, that it is in the domain of gains. All right? So we're going to talk about these three characteristics as we go through this lecture. So at this moment, I just want you to take a moment and look at this curve and see how it is going to fit in with all our discussion later on. So the point that I want to make next is about the diminishing utility, the second point that we talked, right? And it was established long time ago, long time before Kahneman and Tversky, by a Swiss mathematician called Daniel Bernoulli in the 1700s, and it showed that as you move away from the origin, you don't care as much about your wealth. So if the first million, it says, the first million, you get some utility units. You see there's a $10 utility units for the first million, then for the second million, 30, 48 for the third, and so on. And you can see if you already have 10 million, any additional million doesn't give you as much. Okay, so if you only have $0 and you get $100, you're very happy about it. But if you have $1 million, if you get an extra $100, it's a good thing, but probably not the best thing of the day that happens to you on that day. All right, so just take a look at this. You can pause this video, take a look at these two things, and then we can move on. All right, so with that said, I'm going to, throughout this lecture, we're going to keep adding to that value curve, to the prospect theory, and we can continue on with our lecture. The next thing we're going to talk about in the subject, in the topic of prospect theory and value curve, is framing and reversal of preferences. So this is an organ donation chart. It ranks countries by how much percentage of their population consents to donate organs, right? So you can see on the left side we have few countries, Denmark, Netherlands, United Kingdom, Germany, with very low organ donation rate. And on the right side, we see a bunch of them with a very high organ donation rate. The question is, why is this happening? Because if you know your history, your geography, Germany and Austria, the two countries next to each other in this graph, are not that different. They're speaking the same language. They're basically the same type of people. And yet we have such a difference in their organ donation chart. And so is UK and France, depends on which side of the English Channel you are, and Netherlands and Belgium and Denmark and Sweden, and they're all on the opposite side of the spectrum, although we could consider them similar. So what is going on with this? So we're going to go through this example as we talked about. Before we get into it, think about the last time you went to the DMV, to the Department of Motor Vehicle, and took your driver license exam. And on that form, there was a question. Would you like to participate in the organ donation program? And I'm not sure what you did on that form, but this question is a very hard question. It's a very hard question because it's not only about me, how I donate and what do I want to do, but it's a very fundamental question. I do have to talk to my family. I have to ask them about how they feel about it, and it's a very hard question. So when we are faced with hard questions, we do one of two things. First, if the question is hard, we will try to replace it with an easier question. By that I mean, okay, if the question is, would you like to enroll in our organ donation program? And I feel very uneasy about it, I'm going to replace it with a different question. There's something like, what would my family feel about it? How would my family feel about me donating my organs, right? So how would my wife feel about it? How would my family, my kids, my everybody feel about it? And if the answer to that question is something positive, then I'll translate that into the original question, how do I feel about the organ donation? And I check the box accordingly. Or the second choice when we are faced with a hard question is simply to postpone. I'm not ready, I'm not able, I don't want to answer these questions right now, so I'll come back to it later. And we do that all the time until eventually we come up against some kind of deadline. We do this in our life every day until the deadline approaches. So we do one of two things. So we replace with an easier question or we postpone. So what in this case, you cannot postpone. You have to do something about it. And the easiest thing to do is to ignore it. Okay, so let's move on. So on the DMV form, there is a box that says, check the box below if you want to participate in the organ donor program. So because I don't know what to do, I try to ignore it and I don't do anything. I just freeze or move on or ignore it. So I move on and I don't do anything. And therefore, if I don't do anything, it's assumed that I didn't check the box and I am not in. You see? So I can only check the box if I want to, but because I don't know how to do it, I don't check the box and I don't join. Which countries are having this kind of form? The one on the left. Okay? Moving on to the next one, right? The other type of boxes is check the box below if you don't want to participate in the organ donation program. So again, I don't know what to do. I don't check the box and therefore I am in the program. Does it make sense? So that in this case, the countries that are having that kind of DMV form are the ones on the right. So very simple things like checking a box have huge influence over the organ donation program in certain countries. And it is a bigger question than this. It's a moral question and so on. But it goes to show you how an easy checkbox influences people. So the way I framed the question, it made total different responses. It gave total different responses. Okay, so that was a way framing means that we can ask the same question in two different ways and we're going to get two different answers. So let's go through another example. This is a classic example from Kahneman and Tversky, and it says, imagine that the US is preparing for the outbreak of an unusual disease that is expected to kill 600 people. Two alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of this program are as follows. Program A. If Program A is adopted, 200 people will be saved. If Program B is adopted, there's a 1/3 probability that 600 people will be saved and a 2/3 probability that no people will be saved. Which of these two programs would you favor? So write it down. What would you do, A or B in this case? Okay? Just write it down and we'll come back to it. But another example here. If you can A, receive $10 million for sure, the expected value is 10 million, or B, flip a coin and receive $22 million for heads and nothing for tails. The expected value is 11 million, it's higher than 10 million. What would you do? Which one would you pick here? Write it down and then we'll continue on. Example 3. You're being sued for $500,000 and estimate that you have a 50-50 chance of losing the case. The expected value in this case is that you lose $250,000. However, the other party is willing to accept an out-of-court settlement for $240,000. The expected value is that you lose $240,000. The expected value rule would tell you to settle. What would you do? Right? So write it down. What would you do? Would you fight or would you accept the settlement? So in this case, most people would choose A for both, ignoring the EAV value, right? So we don't care about the settlement. We're gonna fight most of the people, and so is in this case when we're gonna get a 10 million for sure, and we ignore the expected value of 11 million, which supposedly, which is higher. So we're not doing that. We're ignoring the EV value. So there's something else here, right? So let's move on. So we should really replace in behavior economics the expected monetary value with some kind of different name called expected utility. Utility is the pleasure I get, the happiness, but we call it utility. So in this case, if we are choosing different expected value, then we are called risk averse, risk seeking, and risk neutral, right? So if I choose the safer bet in the beginning, then I'm going to be a risk averse. I don't expect to gamble. If I go for the gamble, I'm considered risk seeker. And if I don't care, it's a risk neutral. I don't care which one to go. So I'm a risk neutral. Now the important part is this, because these preferences of risk, they change based on the situation. So let's go on and you'll see what I mean. The next example, very similar to the first one, is that in this case of an outbreak of an unusual disease that is expected to kill 600 people, we have now program C and D. Program C is, if we go with program C, 400 people will die for sure. If program D is adopted, there's a 1/3 probability that no one will die and a 2/3 probability that 600 people will die. Which of these two programs would you now favor, right? Now, obviously you notice that this program A, B, C, and D are exactly the same in mathematical terms, right? 200 people will be saved means 400 will die, and so is the probabilities if you calculate them. People usually select program A in example 1 and program D in example 1A. So they go for the gamble in example 1A, and they go for the sure gain of 200 people saved in the first example. So as you can see, your risk preference has just shifted from adopting a sure gain to a gamble for loss kind of situation as we move from example 1 to example 1A. If you need some time, go back and do this math again and see what you have chosen. So it's very important that to understand this point, that when we frame the choices from losses to gains, we can dramatically affect how people answer your question. So again, the same question asked in the two different ways. One in terms of sure gains, and second, the other way in terms of losses, we're going to affect how people make this decision and how they answer this question. So problem 1 and 1A are the same. As I said, they are having the same exact outcomes. Problem 1 is framed in saving lives, and problem 1A is framed in losing lives. And when we make decisions about gains, we tend to be risk averse. We tend to secure the gain and not go for the gamble. okay? But when we make decisions about losses, we switch and we become more willing to take the gamble. So we're going to fight the lawsuit in example 3, even it has lower expected value. We're going to lose more. So this is the breakthrough answer of the prospect theory paper. The amazing insight of Kahneman and Tversky is that you can take the same problem, same objective problem, change the frame from losses to gain, from gains to losses, and get predictably different results. And the beauty of this example that I've given you in this lecture so far is that you can take them outside of this lecture and go and try them yourself in the real world. Any of these examples that we're going to talk, you can take them out of this lecture and go outside in the real world and test them out yourself. And you're gonna get predictably different results. That was the key part. These results are predictable. As we move from gains to losses, people will change their view, their opinion, their preferences. They will reverse their preferences. The question is why? So now we're going back to our first feature of the value curve, and we said there's a reference point in the middle, a 0 point. So it turns out the location of the reference point is crucial when we are framing a problem, and we are going to affect the risk preferences of the decision maker and the outcome of the problem as we place this reference point differently. In problem 1, the lives are saved. Saved from what? Well, from the possible losses of 600 lives. That's your reference point, the loss of 600 lives. So if we save 200, it's a gain. It looks so much better. It's on the right side of the reference point, and it looks so much better, so we're going to take that. In problem 1a, lives are lost. From what? Well, from the existing state of having all 600 people alive. That's your reference point now, 600 people alive. So when you start losing, you're looking at the reference point of 600 people being alive, and if you start losing, you don't like that. The losses are not something that we enjoy, and then you're trying to fight it, right? So you're now gambling to save as many lives as possible. Very good. One more example about the Olympic medalist. If you watch any kind of Olympic game, when they give out the medals, what you typically see is, not all the time, but most of the time, what you see is that the gold medalist is very happy for good reasons. The bronze medalist is also very happy. Happier than the silver medalist. Have you noticed that? So if you think about it, that doesn't make any sense, because silver is better than bronze anytime. Well, then why are the silver medalists less happier than the bronze medalist, right? And it has to do, again, with a reference point. The silver medalist has the reference point of what? Of the gold, right? They were so close to the gold, very close, and they lost it, right? So they're not happy with that outcome. They haven't fought the bronze medalist, so they can be happier. They fought the gold medalist. So when they fought the gold medalist for the championship, in the championship game, and they lost it, they're very unhappy compared to the reference point of gold. Bronze medalist, on the other hand, they have fought for the bronze. They are so happy to be on the podium, right? So you'll see this reference point change every day, all the time in your life. Okay. Another example here, if you're having, and this is very, this happens a lot in the finance world, right? When you're trading, you're buying 100 shares of XYZ Corporation. The value of the stock when you bought it was $20. and then the stock dropped to $10 per share, right? And so what would you do if you want to, what would you do? Would you want to sell or you want to hold on to this stock, right? So you can go back to $20, you can lose everything, go to zero. What would you do? Would you sell your stock now for $10 or not? Well, I don't know about you, but it all depends on your reference point. If your reference point is zero, then $10 obviously looks like a sure gain and you will sell. If your reference point is $20, then you're faced with a loss of $10 per share, and you're probably going to gamble it out and wait to see what happens. Maybe it's going to go back to $20. What should you do is, well, any kind of investment manager will tell you sell the losers and keep the winners, right? So, but again, it really depends on your own risk preference. Okay, so we talk about reference point, and now when you are trying to figure out where to go, when you have a decision to make, you got to figure out what's your reference point, right? Is it a loss? Is it a gain? Where do you stand? And reference points matter. They can be manipulated, and you can nudge people to do whatever you want them to do by changing reference points. More to this later. It happens, framing happens every day. It's very powerful. And some of its consequences are listed here: overselling of insurance, the value we place on what we own, mental accounting, and then something that we're going to talk very soon, the rebate versus bonus differences. In the overselling of insurance, the insurance premium that you pay for your house, for your car, it's a certain loss. It's a premium. You pay it every month. It's a certain small loss that you accept in exchange for a reduction of a small probability of a large loss, right? So, if your house catches on fire, that's a big loss, and you're trying to reduce that probability by insuring it. Now, if you look at this, they call it premium. They're not calling it loss, because you're basically losing it every month. You lose this premium every month, but they don't call it a loss. They call it a premium, which sounds much better than a loss. So it makes the loss more attractive. Same thing when you buy a car, they will tell you that for only a few dollars more per month or pennies a day, you would get this free peace of mind when you're owning your car. And all you have to do is imagine your car being totaled, and that makes it easy sell, right? Any used car salesman know all these tricks. So, but they will go and they will try to put an image of in your mind that your car being totaled, and that you should have insurance because everybody else does, and there we go, you are buying extended warranty for your car, which most of the time doesn't make any sense, because if you look at the typical extended warranty from Nissan, this is a study that has been done, you pay $795 for the extended warranty, out of which over the time you own the car, $131 goes into repairs and $109 admin cost, and $555 is trade dealer profit. So stay away from extended warranties in general, because there's a small probability that will happen. Okay, so the next topic we'll talk is called the value we place on what we own. Also, this concept was brought up by Professor Richard Taylor, currently U of C, and it's called the Endowment Effect. The Endowment Effect basically says that what I own is more valuable to me than what you're offering me to. So there's some kind of emotional value attached to the transactional value of the item. In an experiment that Thaler did back in the 90s, he had two groups of people, sellers and buyers. And the sellers were giving a mug, university logo on the mug, and they they were told to sell it to the buyers. And the buyers would try to buy the mug at some kind of acceptable price, right? So it's a very simple experiment. You can do this all the time. Again, you can replicate these experiments in your own time with your own group. So we have sellers and buyers. The sellers required $7.12 per mug to depart with the mug. The buyers wanted to buy the mug at the median price of $2.87. So we have a little bit of a price discrepancy, pretty significant, between $7 and almost $3. So obviously when you sell something that is like your house, you ask a whole lot more than the buyers is actually given, because you also have what we call an emotional value attached to that thing, that property, that house, that is hard to part with. It makes it hard to part with. This is kind of inconsistent with rational analysis, because we are overvaluing what we own. And you will see this every time you're trying to make a transaction. If I own something, it becomes mine, and it's hard for me to part with it at the price that you're giving me. And another experiment from Thaler, it's in 1998, and Michael Jordan and the Bulls are about to play their final championship game. You would like it very much to attend. The game is sold out, and you won't have another opportunity to see Michael Jordan playing for a long time, if ever. You know someone who has a ticket for sale. How much are you willing to pay for it? Okay, so this is one scenario. The other scenario, it's similar, but in this case, you have a ticket and you would like to go to the game, but how much would you sell it for? Right? If someone will offer you some money for it, how much would you actually sell it for? The results of it is that the people who are trying to buy the ticket were willing to pay $330, and if they had the ticket, they demanded about $1,900 for it. So the question is, why is so much difference, and how can we mitigate this transaction to eventually happen? The question becomes, again, what's my reference point, right? What is it I'm trying to figure out as my reference point? So I want to pause a second and go to the two videos on YouTube that I want to show you. Okay, so this is one video that shows the concept of mental accounting. As you can see, we're going to explain this a bit later, a bit more in depth, but the question is, what is mental accounting and how does it work in our minds? One more video from Ariely. Okay, so mental accounting is one of those anomalies that we talked in the beginning that doesn't make sense from the rational point of view, right? So we have this mental account in our head, like the mason jars that Dustin Hoffman were referring to, and we are only operate within the content of that jar. So when we run out of money in that particular account, we say that we cannot do other transaction, although the money is fungible. So in the example then Ariely said, we we are forced to make this anomaly all over again because we are keeping money in savings account that gives us really low yield, and we also have high debt on our credit cards with a much higher interest rate. And we're keeping this mental account separate, although we should combine them and get rid of the interest that we pay on the credit card. But we're not doing that because of this mental accounting concept. So it is an anomaly, but people do it all the time. Okay, so we're doing this mental budget. All right, so mental accounts affect the satisfaction that comes with the decision that we make. So for example, in another example from Richard Taylor, you receive a letter from the IRS saying that you made a minor arithmetic mistake on your tax return and you must send them $100. You receive a similar letter the same day from your state tax authority saying that you owe them $100 for a similar mistake. So that's one example when we pay $100 to IRS and $100 to the state tax authority. So they're both two losses of $100 each. The other example is you receive a letter from the IRS saying that you made a minor arithmetic mistake in your tax return and you must send them $200. So one loss of $200. Which one does it feel different for you? Which situation is more upsetting? You get two losses of $100 or you get one loss of $200. Okay? So to most people, two small losses is more upsetting than one large loss, despite the fact that it's the same outcome. The two $100 come from two different mental accounts, and they feel worse than one larger $200. Okay, losing $200 is not twice as bad as losing $100 twice. For gains, right? So if we separate it from gains, you just imagine the following scenarios. You're receiving $100 as a gift from your parents for your birthday and also $100 from your grandparents, right? How do you feel if you receive two times $100 rather than your parents giving you $200 and that's it, right? So which one do you feel? Now, if you go back to the value curve, you'll see that from 0 to 100 is a steeper curve than from 100 to 200 because of the diminishing return of the value curve. Same thing for losses, right? So you experience the same loss, which is steeper for twice $100, which is add them together, they feel worse than one loss of $200. So in terms of gains, if you are much more happier to receive twice $100 as a gift, think of that when you are making gifts yourself. So if it's Christmas Day and you want to give gifts, think of giving them one at a time, one gift at a time rather than 10 gifts in one big bag, right? So it makes more joy for the person receiving it. All right, so that was mental accounting. Moving on into some kind of lateral move from mental accounting, we call the rebate bonus differences. In 2001, the United States government gave every citizen some rebate. They call it tax rebate. It was $300, $500, or $600 per citizen, taxpayer, and they paid about $38 billion out. The idea was that you take the money and you go out spending it and you kind of help the economy to come back. 2001 was a little bit of not recession, but short recession. So the idea was that you get some money back, a tax rebate, and you go out and spending it. Now, a study done by Allais, Itson, and Mack in 2005, they were saying that if the government would have used the word bonus rather than rebate, the program would have been much more effective and people would have spent more. The question is why. Before I move on to the next slide, the question is why. What's the difference between rebate and bonus in the idea of mental accounting, what we just said? So pause for a second, think about it, and then move on. So when the rebate word was used, which was the normal word that was used, people spent about 25% and saved 75%. So Allais, Itson, and Mack are arguing if the word bonus would have been used, the people would have spent 87% and saved 13%. On a scale of $38 billion, that's a huge, huge difference. So again, the question is why in the terms of mental accounting. Okay, maybe you figure out by now. If the word rebate or refund is used, okay, that implies that I paid out my taxes from my checking account. So I paid a certain amount of taxes from my checking account to the IRS. And when IRS refunded me the money, I took the same money and put it back in the same account. So it was a two-way transaction from my checking account to IRS and back. Obviously, I'm not going to take out money of my checking account and start spending it all, right? So it's kind of a mental accounting, went from one account back into the account. Now think about the word bonus. What do we associate bonus with? Some kind of free money falling out of the sky. Maybe your grandmother gave you $100 for Christmas and didn't know what to do with it. So the word bonus is associated in our mind with some kind of free money, and because we don't have an account to put it back in, we simply do what we feel like doing. Maybe pay some debt, maybe fix the house, maybe go on to spend it. The idea is that if we don't have an account to put it back into, we'll try to find one for it, and usually is frivolous spending. So that's the idea of rebate bonus. So it makes a whole lot of difference how you phrase and how you frame your wording, your situation, and you will get different responses. Excellent job. So far, so good. We covered a lot of important concepts in behavior economics. This is a very important lecture. If you feel like you should pause, go pause. The readings that I put in the course materials are very important for this lecture. All right. Yes, so if the government would have realized the power of framing, then the $38 billion would have been spent a little bit more efficient. So the conclusion of the prospect theory is that with the discovery, not a discovery, but with the discovery of framing in 1979 by Kahneman and Tversky, the field of behavioral research gets some respect, and that paper is actually, it's given as the starting point of the modern behavior economics, modern decision science, which started in 1979. So we're about 40 years now, and there's research coming out every day, so it's a great time to be a behavior economist. Excellent. So let's move on. What you see in front of you is an actual subscription. This is taken from Dan Ariely. It's an actual subscription to The Economist. This is how it was presented online. So you see three choices, and the subscription is a 1-year subscription to theeconomist.com, online access for $59, the print subscription for $125, and or together print and web subscription for $125, which includes the online and print. Now, pause for a second. This is not a mistake. You are seeing exactly what is, and you're probably wondering, well, that's kind of dumb. Obviously, the choice is obvious. Who in the right mind would buy the middle choice, print subscription for 125 when you can actually buy print and web for the same amount of money? So it's not a mistake. It's a very clever nudge, if you will. It's a very clever framing of from the behavioral point of view from the people at the Economist. All right, so let's see what this gives us. So if you have these three choices, these are the answers. So 16% chose the internet only subscription for $59, and the majority, the overwhelming majority, chose option 3 for 84% for $125, and nobody chose option number 2. And it kind of makes sense. You already got this idea already that choice number 2 didn't make sense. But why is it there, and what's the purpose? All right, let's assume that we take out that choice number 2. If we take it out, we see something very interesting. The framing effect is in place here, and now the choices, the preferences of the subscribers have switched. You see, so option number 1 now, internet only for $59, it's the majority, and the print internet subscription for $125 is now in the minority. So again, when choice number 2 was present, although nobody bought it, it moved people into buying choice number 3. When it was removed, it changed and it switched. So if you were the Economist, what would you do? Well, obviously I want to sell for more revenue, so I'm going to try to sell the $125 subscription. So for that, I created what we call a decoy effect. Okay, we'll come back to this in a second. Let me give you another example. How far will you drive for $7? This is the question. How far will you drive for $7? And this is the example. In the scenario A, you go to the university store and you see a pen that you like for $25. But the store clerk very helpfully says, listen, if you go downtown, 15-minute drive, you can buy the same pen for $7 less, which is you can buy for $18, right? So will you do this or not? So write it down if you do this or not. Will you drive 15 minutes for $7? Or scenario B, which is, well, you saw a suit and it's advertised in the store for $155, but the helpful store clerk is telling you that the same suit is $7 less in downtown for 15 minutes drive. Would you do this? Would you take it? Would you go downtown or not? Right? So most people in scenario A, they did drive to get the cheaper pen, and in scenario B, they didn't. The question was the same. How far will you drive for $7? Will you drive 15 minutes to save $7? But for some reason, the preferences were reversed when we moved from scenario A to scenario B. Okay? Why? The question is why? Well, it's very simple. It's something that we talk about. It's relative to the range effect. $7 out of 25 is a big percentage, right? But $7 out of $455 is not as big. So we don't compare in absolute terms. We need to figure out how to choose by comparison. We compare different things. If I were to try to sell you my cell phone for $1,000, I don't think I'll have too many buyers, right? Because you already know it's $1,000 for a phone, which is not iPhone 10 or whatever. It's a lot of money, right? So and you compared because you already know that you bought something else for a cheaper price, or you know someone who has a same phone and bought it at a cheaper price. So you compare all the time. That's how we make decisions, by comparison. All right. So if that's the case, then now you can see how the Economist subscription made a lot of sense. Let's do another example. Let's assume that I want to send you to Paris or Rome for a week, all expenses paid. Okay, so it's either Paris or Rome for you, all expenses paid for a week. And let's assume that you don't have a strong preference for either Paris or Rome. It doesn't matter to you. They're all kind of the same. You like them both equally. So this is a hard decision. Honestly, you don't care, so either one is fine, but how do you decide? Well, let me help you. Let me see that let's introduce another option. Let me introduce an option that is Rome. I will send you to Rome for a week, all expenses paid, but you don't have coffee in the morning. The coffee you got to buy separately in Rome. Okay, so now your choices become Paris for a week, all expenses paid, Rome for a week, all expenses paid, or Rome for a week, all expenses paid, but no coffee in the morning. What would you do? Did I help you? Did you choose Rome by any chance? All expenses paid, including coffee? Was it make it easier for you to do that? That dummy choice that you saw with the Economist in the middle choice, or Rome, all expenses paid, no coffee, it serves as a decoy. It's a decoy that is a dummy choice. No one wants it, but it does influence the choice of the rest of your decisions, right? So decoy, if you know, it's a dummy thing. It doesn't do anything, but it does influence your decision. Okay, so go back and now look at the Economist subscription in a different way. All right, that's all fine, but how does the decoy influence our choices? Well, in more ways that you think. It affects whom you date or eventually marry. So it's kind of like a big decision. Let's look at these two gentlemen here. One is Denzel Washington and the other one is Lyle. Something, I don't know who the name is. What do we consider to be a handsome or pretty or handsome face, right? We're looking for symmetry. The beauty is in the eye of the beholder, but first thing first, we've got to be symmetric. So if you look at Denzel's face, it's very symmetric and everything. The other guy, not so much, right? So we were influenced about this appearance of beauty. We want things to be symmetric. If you look at someone, we expect that the face is symmetric, and so on. Otherwise, we will immediately observe any discrepancies. So let's play a little game. This was taken from Dan Ariely from the book, and he had two guys, Tom and Jerry. This is Tom, and this is Jerry. They're almost the same, if you will. You don't have any strong preferences for any of them. And the question is, who would you go on a date with if you're a lady? So I don't know which one. So they all look the same, similar to me. I have no idea. It's very hard for me to choose. So Dan Ariely in his book did something interesting. He took one of them and slightly made it a little bit off. So he messed up with the symmetry of the face and make it a little bit off. So let's introduce Tom Prime. This is Tom, this is Jerry, and Tom Prime is a little bit off. It's photoshopped, it looks a little bit off. Who would you go on a date with at this moment? Well, since you didn't know how to choose between Tom and Jerry by comparison, introducing the decoy effect, Tom Prime, is given. It's a given that you're not going to go with Tom Prime, but it helps you choose Tom. Does it make sense? So, because I don't know how to choose between Tom and Jerry, introducing Tom Prime will help me choose Tom because they're similar, but Tom is better than Tom Prime. Very similar situation. Then Ariely introduced Jerry Prime. Now we have Tom and Jerry. Again, we don't know who to go with. And Jerry Prime is a little bit Jerry, but a little bit off. Okay. In this case, most people chose Jerry. Okay, so this is how the experiment went. So obviously, this decoy effect helps us a lot in our daily life. Now, if you think about it, if you want to go out dating, then who would you take with you as your wingman, right? A slightly off version of you, right? In the same time, if someone asks you to go with them to be the wingman, think twice. All right. So, how is this working in business? The decoy version in business. Well, it's very important. William Sonoma introduces a bread maker for $275. Would you buy it? Well, this is a question. It's an absolute term. I know nothing about bread making. I don't know if 275 is a good deal. It's not a good deal. I have no idea. So what do I do if I have a decision that is hard for me to make? I won't do anything. I move on. I'll try to ignore it or postpone it. So what did they do? They introduce a decoy machine, a larger, 50% more expensive bread maker machine. What happened to the original 275 machine? The sales of the machine took off because now people can compare between the original machine and the much more expensive machine, and they chose the less expensive one. Okay, so it makes all sense in business. When you create choices for people or pricing choices, you have to remember to use the decoy effect, because you understand that people are not going to buy the decoy option, but they will be nudged, they will be moved, they will be influenced to go for the option that you want, a Tom or a Jerry. Remember that. All right. So obviously, so far you figure out that we have limited rationality, bounded rationality, but we also have bounded awareness, right? We don't see everything, and as we show in the examples from last session, we're focusing on one area, and then the rest of it is filled by our system one, and it's enough for us to move on with our life and not miss a bit. So I'm going to give you some kind of test here. Without lifting your pen or pencil from the paper, draw 4 and only 4 straight lines that connect all 9 dots shown here. This is the problem of 9 dots. Don't look it online, just try your best at this moment. So use straight lines, don't take your pen from the paper, and try to connect all 9 dots. You can pause the video and you can do it, figure it out. And you probably at this moment, so I'll give you some time, probably you figure out a solution, right? It's one solution that you came up with, and it's something like this, okay? Probably came up with this, something like this. But the question is, are there any other solutions? So pause the video again and see if you can come up with other solutions. And before you do that, I want to go back to this slide and say, do not put yourself in a box. This is the term that says think outside the box. Has been used so much. But in this case, think about it. Do not put yourself in a box and don't constrain yourself. All right, so try it. Any other solutions? What's stopping you from having other solution? It's the only thing that stops you is yourself. Let's see other solutions. You made an assumption that you have to stay within the box. The box could be the literal box made by the 9 points, or the bounds of your mind, right? Is not feasible, technically correct, whatever boundaries you put on our mind. So let's see, can we break that bond? Okay, it's one solution, right? So we can straight lines that are long enough that they can go through all 9 dots. Or you can go like this. You can lay the paper on the surface of the earth, so lay down on your floor, and then go around the world with a line that goes and come back again and again and go through all the lines. No one has told you this is not possible. This was not the question. The only obstacle that you had in doing this was your own box. Or you can draw the dots as large as possible. You can wad the paper into a bowl, stab it with a pencil, and try it until you get all the 9 dots. That's also very creative, and you solve the problem. The problem wasn't that you cannot do that. Or give it to a kid. The kids have unlimited imagination, and as we grow up and we become adults, that's where we put constraints on our mind. But give it to a kid, they will actually figure out the better solution. So when you are faced with a bounded awareness, when you don't know what to do, just ask yourself why not, and try everything that is possibly, use your imagination, unbound your mind, and see what's viable. And then obviously after you come up with many solutions, many ideas, you can take out the ones that are not technically correct. Okay, but do not restrain yourself. So when you're stumped, what to do when you're stumped? These are some ideas. Relax. Don't be afraid to try something different. Let your unconscious mind solve the problem. It's like we usually say, sleep on it, right? Take a break, come back. Brainstorming groups, other people usually help, and don't rule out all the possible solutions too quickly. Generate more alternatives, visualize the desired solution and work backward. This is actually very good. Always start to the end, see where you want to go, and then work backwards to see how you can get there. And don't dismiss ideas until all the ideas are on the paper. In conclusion, this was very important lecture about framing and how reference points work, and how can we influence decisions by using this mental concept of framing, reference point, mental accounting, endowment effect, decoy, and so on. So this is a very important lecture. I really encourage you to watch it again and again. Read the required materials for this lecture, because these 2 lectures they put the fundamentals of behavior economics in front of you. Thank you so much.